Okay, I'm going to go ahead and get started since this is one of my favorite chapters. And because the next chapter is one of my favorite chapters. Last time we were talking about the limbic system. Limbic system is right in the middle of the brain. They used to call it the reptilian brain, mainly because that is the oldest portion of the brain. If we look at other animals, if we look at other mammals, if we look at birds, we look at reptiles, if we look at amphibians, they all have this section of the brain, whether they have the extensive cerebrums, most of them don't, or not, everybody has all of these parts. So that's obviously one of the basic parts of the brain of living creatures. So the limbic system is part of just about everybody's brain. The limbic system encompasses a lot of things, and you can see all the structures: the basal forebrain nuclei, the mammillary body, the olfactory bulb, the amygdala, the hippocampus, the perihippocampal gyrus, the cingulate gyrus, the anterior nucleus, and the dorsal thalamus. These two are extremely important, the amygdala and the hippocampus. Hippocampus, of course, is the area of the brain that allows us to remember things. And of course, all animals would require that to be extensive, relatively extensive. The amygdala has to do with emotion. It has to do with survival. The amygdala, if you have a amygdaloid reaction, of course, it allows you to be aggressive. It allows you to react to a situation so that you can protect yourself, so you can survive. So the amygdala and the hippocampus is extremely important to just about all living structures with brains. Studies using electrodes implanted in the brain have discovered that most of the areas of the brain do not produce positive reactions. And of course, we have we've done extensive studies doing this, trying to find areas of the brain that cause this or cause that. But the reality is, the area of the brain that is the most sensitive turns out to be the hypothalamus, that tiny little structure right in the middle of your brain. We have discovered a pleasure center in there. We've discovered centers of the hypothalamus that create aggression. The most apparent area is a large tract that ascends from the midbrain to the hypothalamus, a region referred to as the medial forebrain bundle. This area seems to have something to do with food-seeking behavior in lower animals, not especially in humans, but in lower animals, of course, this is what drives them to find food. And of course, for most animals, securing food is one of the most important things that they do throughout the day, of course. That otherwise, they don't find sustenance. They are not able to survive. Physicians have noted that the differences of people with localized cerebrovascular accidents. Cerebrovascular accidents is the medical term for a stroke. What we refer to as a stroke, what the layman refers to as a stroke. So sometimes you'll see a capital C, capital A in somebody's chart, and if you see that, it doesn't mean cancer. Cancer is capital C, small a, is the abbreviation for cancer, but capital C, capital A refers to a cerebrovascular accident or a stroke. And of course, there's three different types of strokes. You can have a hemorrhage, you can have a blood clot, or you can have what they refer to as an aneurysm. And an aneurysm is a ballooning out it's a weakening of the blood vessel so that it balloons out, and then eventually if it bursts, there's a great deal of bleeding that takes place. And of course you think of that as a hemorrhage, but only after it breaks. Before it breaks, of course, now you've got this pocket of expanding blood, and because of that, of course, it puts pressure on the area, and it can cause all kinds of interesting problems. So that's how an aneurysm works. So there are three basic types of stroke: hemorrhages, blood clots, and aneurysms. A stroke in the right parietal or the temporal lobe causes undue cheerfulness or joking, denial of illness, and apathy. So strangely enough, from the way that people react to whatever's going on in their brain, we can determine what area of the brain they have a problem in. So if they act happy, which is kind of interesting, if they're in denial and they tend to be fairly apathetic about just about everything, we know that the stroke is in the right parietal or the temporal lobe area. A cerebrovascular accident in the left frontal lobe, especially in the basal ganglia area, can cause a lot of different problems. Now, there's a reason why we see so many of these, and that's because it is around your forehead. So if you get a blow to your forehead, of course, it may potentially cause bruising. It may disrupt the structures of the blood vessels in that area. And because of that, we see a lot of strokes that are actually in the left frontal lobe because of blows to the head. It's on the left side. So the vast majority of people in the United States or in the world are right-handed, about 90%, actually a little bit more than 90%. So if they swing at somebody, if they strike somebody, they will probably strike them in the left frontal lobe. So if a parent gets angry at a child and slaps them, of course it's a blow to the head, they may potentially cause damage in the left frontal lobe. One of the things we do see with people with left frontal lobe blood clots or hemorrhages is depressed mood, daily mood variation, loss of energy, anxiety, restlessness, worry, weight loss, decreased appetite, early morning awakening, delayed sleep onset, social withdrawal, and irritability. One of the things, they did a study back in the 80s and 90s looking at individuals that had been incarcerated for violent crimes. And one of the things they discovered was that there was they were more likely to have damage in this area. Since this is the reasoning area of your brain, is your frontal lobe. So potentially it had something to do with a blow to the head. And this may be one of the reasons why in select populations where you have a number of individuals with problems with the law, we may see this because we have a population where there's an authoritarian parenting style, and therefore there's a lot of striking taking place. And if that is the case, then potentially what we have is we have damage to this area, causing all these interesting problems. And of course, if this takes place over an extended length of time, from childhood into adolescence into adulthood, then potentially, of course, we could have an individual that looks like they have antisocial personality disorder, lack of empathy and whatnot. Bilateral hemispheric lesions or any lesions in the brain can cause frequent brief laughing and or crying. Crying that is not caused by sadness, social withdrawal secondary to emotional outbursts. And of course, for a while they had commercials on television talking about people with bulbar or some kind of bulbar problems, and these were their symptoms. And it's not because of a lesion, of course. It had to do with strange interactions taking place in that area. Cerebrovascular accidents in the right basotemporal or right orbitofrontal area can cause elevated moods, increased energy, increased appetite, decreased sleep, feelings of well-being, pressured speech, flight of ideas, and grandiose thoughts. Of course, this looks very close to schizophrenia or a form of schizophrenia, schizotypal behavior, except for the happiness, of course. Anyway, you would, or bipolar disorder. potentially you would see this individual as having a mental illness rather than having a stroke in a select portion of their brain. Studies looking at the fear response in animals and humans have discovered that the amygdala part of what used to be called the reptilian brain is the structure that mediates fear. Pictures of fear-inducing images shown to individuals will elicit blood flow to the amygdala. And as you can see, this is a limbic system right here, hippocampus. The amygdala is right at the end of the hippocampus. It's a relatively significant structure, but as you can see, you have one on each side. So potentially, if something happens, if an emotion is aroused, then one of the reasons that the emotion is aroused is because of the amygdala. And you can see it right there. It's right behind your eyes. It's right in the middle of your brain. When a woman without an amygdala was shown a picture of a woman smiling, she recognized happiness. That's not an extreme emotion. Happiness isn't. Potentially we are happy all the time, or at least we feel good, relatively good all the time. But when they showed her a picture of someone with an extreme emotion, in this case it was an individual registering fear, she didn't recognize the emotion because that information needed to go into her amygdala. She didn't have one, of course, and since she didn't have an amygdala, she didn't recognize the fear in the woman's face. Researchers looking at aggression have discovered that cross-species elevated androgens means elevated aggressive tendencies. And this is one of the reasons why we talk about testosterone so much. It's because we've seen this in lower animals. We can do research with lower animals where we increase their androgen level. And one of the things that we have seen with increased androgens is aggressive behavior, is far more aggressive behavior. So we can theorize as to what's going on with these select individuals. As animals evolved, let's just talk about humans. As humans evolved, of course, the individual with the most testosterone would be the most aggressive individual. Now, potentially, if we look at a whole room full of males, one of the things we're going to see is a fairly constant level of testosterone. And the reason we're going to see that is because in order for people to live peacefully together, the males needed to have a select amount of testosterone. If they had too little, they didn't reproduce. If they had too much, they became overly aggressive, and potentially, of course, they were taken out of the society because of their negative behavior. And of course, as we have mixed populations together, as one population has visited another population, perhaps to conquer them, one of the things that we have seen is some people are far more aggressive than others. One group that seems to have been fairly aggressive were Vikings. Were the Vikings from the northern countries, from the north of northern Europe, Sweden, Norway, Finland, Denmark. Those areas produced men that would go out and would raid other areas. So it may be that people that live on farms and just sit there and don't do a whole lot, these individuals have a lower testosterone level than a population that is relatively nomadic and tries to create chaos, tries to and attacks other individuals. It's just a thought. It's just a thought that nobody has really ever talked about. But it seems that there are populations that do wander around and have attacked people in the past. So potentially, of course, the individual that's just sitting there and doing animal husbandry and planting corn and whatnot those individuals have a lower testosterone level than the individual that jumps on a trusty steed and wanders off into the are and attacks other individuals. Potentially males that are in the military have higher testosterone levels. Potentially females who are in the military have higher testosterone levels. I was thinking about this the other day, and there's a couple things I can't talk about, but it's possible that just being in the military raises your testosterone level. For one thing, you're in a situation where they're training you to have a high testosterone, in that they're training you to be aggressive in case of enemy attacks, of course. Supportive evidence: when a male subject species is castrated, androgens, of course, and aggression will drop in the individual. We do know that as men age, their testosterone decreases about 10% per decade after age 40. So potentially, I'm not as aggressive as I was 30 years ago or 40 years ago because my testosterone isn't nearly what it used to be. Injecting testosterone into castrated individuals lead to increased aggression in this select individual. So, and that's one of the things that I have done in the past. That didn't sound right. That's one of the things I've done in the past working in clinics. I have given people testosterone shots. Usually it doesn't have to do with lack of aggression. Usually it has to do with a low T. For a while there, they were talking on television about low T levels, and that you need to get your T level checked to make sure that your testosterone is not going down. I have a feeling that with the urbanization, and this is one of the things that we have found, that people that live in close proximity to a lot of other people, they have to maintain a lower testosterone level for fear of reacting to whatever's going on. So this is really kind of interesting. Here I've been talking about testosterone for the last 10 or 15 minutes. I apologize. It's really a fascinating topic. There's a movement right now to discount all of this. It's kind of a feminist reaction to all of the ideas about androgens and testosterone. I really kind of find it fascinating how these things play out sometimes. So this is one of those topics that select individuals don't like. So if you looked at this topic, potentially you wouldn't find anything that was newer than 4 or 5 years, since there's really not a whole lot of research being done with it right now. This is kind of an old idea that some people don't like because we're in science right now. We seem to be dealing with a lot of individuals that they want to make everybody the same, and the reality is, of course, we're not the same. Certainly, we're not the same, and potentially biochemically, we're not the same. It may be that one of the reasons why all these crazy white guys are picking up rifles and firing hundreds of rounds, thousands of rounds in the case of the guy in Las Vegas. It may be because there's something wrong with that population. That didn't sound right. It may be that they have had high testosterone levels in the past, and they have a higher, overly aggressive. I'm not saying they're overly sex. Sex doesn't really have that much to do with it, but it does have to do with violence. And so here we've had these two cases in the last 40 days of individuals that have just gone seemingly berserk, and they were both white males. Seems to be a problem. I don't know. Maybe we need to look into this more and pretend that it's not a problem at all, or that we are all exactly the same. It just doesn't make a lot of sense to me. We've done research looking at females. Females have testosterone levels as well. They don't have testicles, certainly, but their ovaries produce testosterone just like males' testes produce testosterone. It doesn't produce nearly as much. But one of the things that we have seen is that women with a higher testosterone level are more aggressive. We've seen this in military personnel. If we send a lady through combat training, one of the things we have discovered is that she will have a higher testosterone level while she is in that mindset, that combat aggressive mindset. In a study looking at female prisoners, it was found that women in prison for unprovoked violence have higher testosterone levels than women in prison for defensive aggression. So these women had or did maintain a higher testosterone level. One of the things that we don't talk about a lot, but as far as domestic violence is concerned, actually perpetrators, women are slightly more likely to or prone to domestic violence than males are. The difference between males and females is that most males are bigger than most females. Not always, of course, certainly not. But the reality is that since males are bigger than females and they maintain more muscle mass, that they tend to do more damage. And for that reason, of course, we don't really talk about females attacking males, but the reality is it happens all the time. And actually it happens more frequently than males attacking females. And of course, because of the dimorphism, the larger size of the males, human males do tend to be larger than human females. If we look at other creatures like cows, for example, the bull tends to be larger than the heifer. Dogs are about the same size, cats are about the same size. Birds tend to be about the same size, except if you look at peacocks and peahens. But there is a lot of dimorphism out there. Gorillas, for example. The male gorilla is much larger than the female gorilla. Chimpanzees are about the same size. It's really kind of fascinating. When we looked at veterans, when we found veterans suffering from antisocial behavior, these individuals had higher testosterone levels as well. And of course, this is one of the problems with the military. The military trains males to be aggressive. And sometimes, of course, this leads to an increase in testosterone that is a fairly permanent situation. And these individuals sometimes will turn out to display antisocial behavior. Not always. As a matter of fact, most frequently, they are able to return to society without any problem at all. Studies of monkeys in lowered levels of serotonin show that there is a negative correlation between serotonin and aggressive behavior. And of course, we know that serotonin is the neurotransmitter in the hypothalamus that tempers the testosterone levels. And for this reason, we have doing studies looking at testosterone. If the male does have a high testosterone level, then one of the things we see is a higher serotonin level to temper that. And that may be one of the reasons why people are able to leave a combat situation and to not act too insanely, I guess. But of course, serotonin is the controlling neurotransmitter in the hypothalamus. One of the things that we've noted, I have already talked about testosterone as far as males are concerned. If we look at all human males, there is an average level of testosterone, and most males are right around, I mean, that's the norm, of course, is a testosterone level that is a select level. One of the other things that we see is a similar situation with serotonin. Serotonin is tempering the testosterone. And so the reality is that if we, draw blood from, a whole classroom full of males, one of the things we're going to see is normal testosterone levels, and we're also going to see normal serotonin levels. In other words, as one increases, the other one increases to control it. Serotonin is not the only neurotransmitter that controls aggression. Hormones that control testosterone levels and the GABA system also play a role. So GABA, of course, is the neurotransmitter that controls anxiety. So one of the things that we do if you have a problem with anxiety is that we increase your GABA level. We also know that the GABA is what puts you to sleep at night, an increased GABA level. So the GABA level also tempers the testosterone. Okay, let's shift gears a little bit. Immunity, we're going to start talking about why we are alive, why we are the ones that survive. The reason that we survived is because our immune system was able to fight off all the diseases that came our way. One of the lucky things about all of my students is that they are young enough not to ever have come in contact with some of the diseases that were common diseases when I was a child. I was born in 1949, so I grew up in the 1950s. In the 1950s, we didn't have inoculations against a lot of things, measles for one thing, measles, mumps, chickenpox. Now, of course, you can get inoculated against those things, and potentially you won't have any of these childhood diseases. These diseases that I had to suffer through as a child. Chickenpox, I had chickenpox, I didn't have the mumps. Did I have the mumps? No, I didn't have the mumps. But I had chickenpox, I had the measles, I had fifth disease, oddly enough. And the reason that I had to suffer through these is because I wasn't inoculated against them, because there was no inoculation back then. But as time has gone by, we have developed a way to inoculate you against these diseases. One of the things that happened when Europeans first came over to the New World, to the Americas, is that they brought diseases with them. Now, why in the world would, we're talking about two human populations, why in the world would one human population be carrying more diseases than the other? Well, as it turned out, Europeans evolved looking at a lot of diseases. And the reason that these diseases were being developed in Europe is because they had an animal, a domestic animal that had an immune system that was very similar to humans. And this animal is the pig, is the swine. And even if you go to Europe today, people are actually living with their pigs. As odd as that sounds, when I was in Germany, and I was there from 79 to 82, we had there were a lot of individuals living in our village. I lived in a little village right on the French border. I was living in Germany, of course, but it was right on the French border. It was a town called Mauschbach. And it was very common in that village for people to build their barns, and then they would build their houses on top of their barns. So the bottom layer, the first floor, was always, sometimes it was a basement, or sometimes it was the first floor, but that was the barn. That's where the cows stayed, especially where the pigs stayed. Pigs are very popular. Pork is a very popular meat in Germany. They make a lot of sausage, and it's usually pork sausage. So they would raise their pigs, and they're on the first floor. And one of the things that they did, they fed the pigs whatever they fed the pigs, but they also fed them whatever was left over from their own meals. And because of that, they were swapping spit with the pigs, they were feeding them their own refuse, which was kind of an interesting situation. But what happened was, if somebody had a cold, somebody had the flu, of course, whatever they touched, whatever food they started to consume and that didn't, that was fed to the pigs. So in essence, what was happening, they were also feeding them the viruses, whatever viruses and bacteria, whatever toxins were coming in contact with the humans were also coming in contact with the pigs. One of the things that happened, of course, when the Europeans started coming over to the Americas, they brought their own food, and some of the food was in the form of livestock. The livestock included horses, sheep, pigs, and cows, of course. So they were bringing all these diseases over to the Americas. Well, the people in the Americas had never seen anything like this before. There were no pigs. Actually, there is an animal that lived in the Americas that had a similar immune system, and that animal was the turkey. And they've done studies looking at all of this, and what they've determined is that the Europeans were a cesspool of all of these horrible diseases, measles, mumps, chickenpox, smallpox, and some of these diseases wiped out whole populations of American Indians, or the peoples that were living in the Americas. If we talk about the estimates of how many people were living in the Americas at the time, some people, Europeans would claim that it was a relatively small number, maybe 1 million people in both North and South America. But other estimates have been as high as 100 million people, which would have made the Americas the most populated continent on Earth at the time, of course. Asia did have a large number of people as well, but of course the Americas may have been fairly heavily populated, and of course with all the diseases that came over, since there was no immunity, a large percentage of the population died from all of these horrible diseases, and we can talk about the invasion of the Aztecs or the Incas. And one of the problems, of course, was as soon as they made contact, whatever disease was prevalent on shipboard with the Europeans suddenly became a death knell for whoever they came in contact with, whether it was the measles. The Europeans aren't dying from measles or the chickenpox usually, but since there was no immunity, it just ran rampant through native populations in the Americas. So immunity is really important, and we can ask the question. And whole villages would die, whole populations would die. They talk about the Grovans were a fairly large tribe, maybe as many as 60,000 of these guys living in central Montana up into Canada. Fairly extensive, fairly aggressive group of individuals. They talk about having 600 lodges. They had 600 lodges, and smallpox came in and went through the tribe. It's a tribe that when somebody is sick, then all of the extended family will come to try to help the individual, and of course, as long as it's nothing virulent, then that is a big help. Social, have all that social support. But one of the things that happened, they went from 600 lodges to 60 lodges, so they lost 90% of their population. And after that, they weren't the power that they had been before, since they lost so many warriors. And the other thing that happened was it seemed that it was the females that were doing most of the ministering to the sick. Because of that, they lost almost all their female population. So they talk about going to another tribe and bartering or stealing females in order just for this tribe to survive. And one of the groups that they did that with were the Arapaho. Of course, the Grovon theoretically are. The Arapaho, their name is the Anin, and the Grovon are the Aaninin. So they went down to the Arapaho, and they had no females, so they had to marry somebody, and of course the Arapaho were there, and they weren't dying at the same rate. So the two tribes mixed to some extent. So we can talk about immunity. Immunity is very important. It's really kind of an interesting. This is what I did when I was in the service. I was a laboratory technician, and one of the first things that we would do if somebody came in that was sick, one of the first things we would do is draw their blood and look at the number of red cells that they have, the number of white cells they had. And we would look at the kind of white cells they had. And you would think, well, just the number is important. Yeah, the number is important. As far as that goes, do you have enough white cells? But the other question was, which white cells were the most prevalent? We had normal levels of neutrophils, normal levels of lymphocytes. We would look at a blood smear and try to determine, we would do what is called a differential, where we were identifying each cell that we saw. And what we were trying to determine was which cell was the most prevalent. And there's a reason for that. And the reason is because with an increase in a select cell, we could tell what the problem potentially was. So one of the first things that we always did, if somebody came in that complained of having a cold or having the flu, first thing we did was draw their blood so that we could look at a blood smear and determine what type of white cells that they had. From that, of course, we could determine whether it was a viral infection or a bacterial infection, or whether it was an allergic reaction, or potentially they had been poisoned. If we look at the different types of lymphocytes, lymphocytes, one of the things that we see is that each one fights something different. The basophil is increased when we have a problem with toxins, especially heavy metal toxins. These are basophils, these two dark cells up here. If you look at these, you go, oh, geez, they all look alike. But the reality is they're different colors, they have a different shaped cytoplasms, and this is what we were identifying. It's really kind of fascinating. So you should be able to look at a blood smear and determine if the individual has been poisoned with some kind of a toxin, because the basophils would be increased. Eosinophils fight allergens. They fight parasites. So if an individual comes in with a cold, we could draw their blood, and if they had an increased number of eosinophils, these orange ones, and that's eosin is the orange dye actually that dyes these guys. If we saw an increased level of eosinophils, then we would know that the individual was probably didn't have a cold, didn't have the flu. They probably were allergic to something. Or if they came in with diarrhea and we drew their blood, if the diarrhea was caused by a bacteria, we would see an increased number of neutrophils. But if the diarrhea was caused by a parasite, we'd see an increased number of eosinophils, and probably an increased number of neutrophils as well, but we would also see an increased number of eosinophils. And you ask, well, what's a normal number of eosinophils? What's a normal number of basophils? Well, normally we don't see any of these guys at all, hardly any basophils at all. So if we saw, and the normal goes up to 5. So if we saw 10, we would know that there was something going on, there was some poisoning going on. The normal number of eosinophils is 0 to 5. So if we saw 10 or 15, we would know that an allergic reaction was taking place, or the individual had been contaminated with a parasite. Lymphocytes fight viruses. Most of the most virulent problems that we have, smallpox, measles, mumps, chicken pox, all of these are caused by viruses. And of course, most of the things that killed off the native populations when the Europeans first came here were some kind of viral infection, smallpox, chicken pox. Of course, at the time we didn't know what a virus was, but now, of course, we can determine what the problem is by looking at the number of lymphocytes. So if they have the flu, for example, we would see an increased number of lymphocytes. If they had, what is the disease I'm thinking of? Mononucleosis. If they had mononucleosis, we'd see a huge increase in the number of lymphocytes. It's a viral infection. It's caused by, it's caused by a lot of different things, but it's caused by a virus, the Epstein-Barr virus. So we would see an increased number of lymphocytes. Not only that, we would see abnormal forms. We would see immature forms because the body's trying to fight off the viral infection. Therefore, it would pump out just a huge number of these guys. And some of them would be immature. So if it was a viral infection, a fairly virulent viral infection, one of the things that we would see a lot of immature forms of these lymphocytes. Normally, if you're not sick and we draw your blood, we would still do a blood smear. Your white count would be probably in the 5,000 range or 6,000 range. The majority of the cells that we would see would be neutrophils. Neutrophils are wandering through your body. They're finding bacteria to destroy. The reality is that we have bacteria there's bacteria all over the place. We have bacteria in our digestive systems. We have bacteria on our hands. We have bacteria on our faces. So should we kill these bacteria? No. These bacteria, some of these are good bacteria. They will not cause an infection, and they keep bad bacteria from getting on our hands. They will fight the bad bacteria, and they will kill them if they come in contact with them. So if nothing was going on, if we were perfectly healthy, as all of us, well, there's only one of me in the room, but I'm fairly healthy today. If I drew my blood right now, my white count would probably be somewhere between 5,000 and 6,000. And the vast majority of my cells would be, maybe as many as 50 or 60% would be neutrophils, and that's because the bacteria it causes a lot of acute problems. Viruses cause some acute problems, but they also cause chronic problems. So the vast majority of my cells would be neutrophils, fighting off whatever bacteria I have. I just had an infection in my finger. You can see the scar right there. I got a splinter in my finger. I was hauling wood and I didn't have gloves on, and now I have an abscess. I had an abscess. I had a lesion on my finger. I had another one. Oh, it's right over here. Anyway, yeah. So I got stuck with a splinter from pine, and it caused an infection, and it was there for like 10 days. I couldn't get the splinter out. Finally, it built up enough, and it pushed the splinter to the surface, and I was digging around in there with a needle, and I popped out this wooden splinter. And now, of course, there's no invading bacteria in my system, so it's going away. The abscess is gone because the bacteria is dead. Neutrophils. Monocytes, these are monocytes right here. No, these are monocytes and those are lymphocytes, I'm sorry. Yeah, these are the monocytes. They're a much larger cell. An immature lymphocyte looks like a monocyte is the problem. These fight cancers, the monocytes do. They engulf them. And that creates a benign tumor. If your immune system is able to isolate the cancer, what it will do, it will encapsulate it. It will cover it with so that it can't metastasize, so that it can't go anywhere. So we will create this collection of cells, and it becomes a benign tumor. If you cut into it, of course, what they'll do is they'll try to take the whole thing out, and they'll cut all the way around it. And if they find it encapsulated, then they refer to it as benign. If it is free to leave that area, then they call it malignant, because it hasn't been encapsulated by your immune system. This is constantly going on in just about everybody's body. My immune system is, and I'm going to explain to you why my immune system isn't nearly as strong as everybody else's, but I don't get sick very often. The problem is, of course, if you become immunocompromised, then all of these things, there are possibilities that you're going to have a viral infection that you can't fight off, or a bacterial infection that you can't fight off. The allergens, you're going to have allergies all the time. If you get poisoned with something, your body's not going to be able to fight it off. But really the most serious one is cancer. If you develop a cancer and you are immunocompromised, like if you're under a great deal of stress, then potentially a cancer can grow. And of course that we see that all the time. An individual that has been under a great deal of stress, this individual will develop a cancer. Once upon a time I was fired from a job that I loved. That summer, I was fired in July, and that summer I had a heart attack. About 2 months later, I had a tumor taken off my forehead. So I was immunocompromised, mainly not because I was sick, but because I was depressed, because I had been fired from a job that I thought I was going to keep for the rest of my life. Anyway, I developed a tumor on my forehead, which was really kind of interesting. I had this lump, and it kept getting bigger and bigger and bigger. And I finally went in to the doctor, and he excised it. He cut it out. And of course, he didn't just cut out the tumor, he also cut around the tumor to make sure nothing had leaked out, no cancerous cells had leaked out. It was on my forehead. It was really kind of curious. Anyway, when he sent it in to be inspected, to be investigated, one of the things they discovered was that it was benign. The reason it was benign was because it was completely encapsulated. Why? Because my immune system was strong enough. It was weak enough for the cancer to develop, but it was strong enough to fight off the cancer. And for that reason, I'm alive today. That was 7 years ago. But I had this tumor taken off my forehead. Fascinating stuff. Anyway, these are monocytes right here. This is what they look like. Monocytes, and all these bacteria kill things in different ways. We're going to talk about how lymphocytes kill things. But all the granulocytes, they engulf things. They will capture them. They will come up to them, and they will engulf them. And that's how the monocytes work. That's how the neutrophils work, the basophils, and the eosinophils. That's how they all work. Fascinating stuff. And of course, I've worked with this for 30 years, so I find this just fascinating, the way that all these things work. The other thing that I will tell you is that I never get sick. Obviously, I had the tumor on my forehead, I had a heart attack, but those were both conditions. I rarely get sick, but there may be a reason why sometimes things are more dangerous for me. But then again, things are less dangerous for me. One of the things that one of my experiences in my life is that I've worked in a medical situation. So if somebody came in with the flu, I came in contact with the flu. I was working in a pediatrics clinic in Vienna, Virginia, which is just south of Washington, D.C. My wife was stationed at, not the Pentagon, but at Bolling Air Force Base. I was working at the pediatrics clinic as a laboratory technician. I was there for two winters, and during both of those winters, they had a flu epidemic. And one of the things that we did in our clinic, we had all these kids coming in We were the ones that determined, we were trying to figure out if it was influenza A or influenza B. So that was what we were, was one of our jobs. So I came in contact with all these kids, and not only that, but in order for us to, we needed a specimen. And the way we took a specimen, we didn't take a cotton swab and stick it up their nose. What he did a nasal wash, where he took saline and he shot it in one nostril, and it cleaned out the sinuses, and it all came out the other nostril. Hi, Joe, how you doing? It all came out the other nostril. So here he came into a bag. It was really kind of fun. And I didn't have to do it. He was the one who did it. My doctor was doing it. But I had to take those specimens and I had to ship them out to the state laboratory. So here I am collecting all of these specimens. I've got all this nasal wash, which is a mixture of mucus and saline. And they were taking it, of course, and they were the ones that were trying to determine if it was type A or type B. But we had these two epidemics, and we were collecting more specimens than anybody else in the state. Potentially the reason is because the flu comes out of Asia. The flu usually comes out of Asia. And it has to do with pigs again. You don't have any pork in there, do you? I'm just kidding. It doesn't matter. Anyway, yeah, so the flu comes out of Asia every year. The reason it comes out of Asia is because Asians live with their pigs. Just like, well, not like just like the Europeans do. They live with their pigs and they fertilize their fields with human waste. And because of that, the pigs will root around, of course, in the human waste and whatnot, looking for roots or whatever they're looking for. So they're coming in contact with all the diseases that humans have. And because of that, the flu tends to evolve every year. So this year, of course, if you get a flu shot, you're going to get a flu shot for the type of flu that we were suffering from last year. What they try to do is determine whether it's type A or type B. There are actually a lot of different structures, but it can be 30% B, A, and 70% B, and that's what they're trying to determine. The two different types of influenza are actually completely different, and since they are completely different, one of the things that has to happen is that you need to get a inoculation against 30% A and 70% B. And this is one of the reasons why the flu shot doesn't have to work every year. A lot of times it will not work. Yeah, that's how the immune system works. Why am I talking about this? Oh, I was talking about coming in contact with those two flu epidemics. And I didn't get sick. All these kids are coming in and they've got a lot of nasal congestion and whatnot, and they feel crappy and their joints are all achy and whatnot. So we were dealing with them and trying to determine we're trying to make them feel better. At the time there were no antivirals, but we were trying to determine what was going on with these kids. So we came in contact with all these kids, and I shipped out all this stuff, came in contact with it, and I didn't get sick. Neither did the doctor, of course, but then again, he's coming in contact with these individuals on a relatively frequent basis. You would think if this stuff was really virulent, that all of the medical personnel would be the first ones to get sick, or at least the second ones to get sick. So you have to ask yourself the question, this was in October and November, and usually the flu will walk from the west coast to the east coast. It slowly makes its way across the country. That's the way it normally works. But there are pockets of where the flu will strike second or third. Usually will strike first on the west coast, like San Francisco or Los Angeles. And then all of a sudden, we find the flu in New York, Chicago, and Washington, especially Washington, D.C. Washington, D.C. was a relatively quick area to become infected.
because of all the diplomats coming from Asia to Washington, D.C., and they were bringing the flu with them. And for that reason, Washington was always one of the first areas that got sick. It takes about, in order to create a flu shot, they have to come up with a vaccine. It takes about 6 months. And this is one of the reasons why they can't just wait until the flu develops and then come up with a vaccine. It doesn't work that way. It takes too long to develop the vaccine. By the time they would develop the vaccine, knowing exactly what it looked like, it would take too long and the flu would be gone anyway. Okay, so I don't get sick, and the reason may be because I come in contact with so much stuff. Mononucleosis, I've never had it. The flu, I come in contact with this stuff all the time. Some individuals are more susceptible to diseases because they come in contact with it so frequently. I know an individual that works in a veterinary clinic, which she probably shouldn't do because she's very sensitive to the mange. Humans don't get the mange hardly ever unless they come in contact with it, and they're very sensitive to it. And she seems to be more sensitive than just about everybody else, which is kind of an unfortunate situation. The immune system is very adaptive, and it maintains itself through several different structures. And for this reason, of course, if a new disease comes up, you're able to fight it off. Potentially, you're able to fight it off, as long as you've got a fairly strong immune system. There are 3 basic structures to the immune system. The thymus, which is right behind your heart, your spleen, which is right underneath your lungs, and your long bones, the bone marrow in your long bones. This is where all your cells are being either made or stored. These are the 3 major areas. The B lymphocytes comprise the humoral immune system. These cells are produced in the long bones, and almost all of your immune system is going to come, all of your white cells are going to come from the bone marrow and your long bones. If you have leukemia, which is cancer of the white cells, leukemia, it usually has to do with the long bones. You have you're putting off diseased cells. So one of the things they will do if you have leukemia, if they can't control it, one of the things they'll do is they'll radiate your bones, trying to kill off your bone marrow. Because your bone marrow is producing cells that aren't working. Then they will inject new bone marrow in there. But of course, this is a tissue transplant. So they have to make sure that your immune system won't kill off all of this bone marrow. So they have to match it. It's kind of like matching blood. If you have type O blood and I have type O blood, I can give you blood potentially. But if you have something in your blood or I have something in my blood that you have an antibody against, then if I give you my blood, you'll destroy that blood. Your immune system will destroy that blood. And we have to do exactly the same thing with bone marrow. B cells produce antibodies or immunoglobulins that either directly neutralize the antigens of the foreign body, or they enhance the destruction of other cells. Really kind of fascinating how your immune system works. Sometimes, remember, we have those engulfing cells, and they will engulf whatever the problem is, or they will attach an antibody to it. They will attach an antibody to the antigen, and then another cell will come and destroy it. These cells are called natural killer cells. What a cool name for these cells. So those are the 3 major areas of our. We also have repositories. We have a repository in our lungs. Our lymph nodes are repositories for our white cells. And we have lymph nodes all over our bodies, of course, spatially in our groins and in our armpits. But there are repositories in our lungs as well. And in our digestive system. The repositories usually are in areas where infections are possible, like in the lungs, with respiratory infections, or in the gut with
bacteria that get through the digestive system. Normally, if you eat something with a lot of bacteria in it, no offense to whatever you're eating right now. If you eat something with a lot of bacteria in it, because we have stomach acid, the acid will destroy the bacteria. So you really don't have to worry about it. We've got tons of bacteria in our mouths all the time, and we're swallowing. It goes down into our digestive system. We don't get sick, and the reason we don't get sick is because our stomach acids are so strong that they kill off any bacteria that's not supposed to be there. We have bacteria in our stomachs. We have bacteria in our small intestines. That bacteria is there to help digest our food. We have lots and lots of bacteria in our bodies, and these are very important bacteria. Cell-mediated immunity involves lymphocytes formed or converted in the thymus behind the heart. There are 3 types of T cells. There are T helper cells, and of course, if you know anything about the AIDS virus will invade the T helper cell, and it will replace your DNA with its DNA. And because it replaces your DNA, now the T helper cell thinks it is an alien structure. And because it's an alien structure, your own white cells will kill off the T helper cells. So the T helper cells, the job of the T helper cell is to wander through the system and attach antibodies to antigens. So it's telling the immune system that there is something that it needs to kill. And that's the job of the T helper cell. It produces interleukins and lymphokines. Interleukins and lymphokines are forms of antibodies. And so it will wander through the body and it will attach these antibodies to antigens. And if you have AIDS and the AIDS virus has invaded a number of your T helper cells, all of a sudden you don't have any of this stuff anymore. You don't have T helper cells wandering through your body attaching antibodies. So suddenly you become immunocompromised. And since you're immunocompromised, if you come in contact with a bacteria, with any type of bacteria or something that normally would be knocked out by your immune system, now all of a sudden it doesn't have the antibodies to attach to the antigen of that problem, and you will develop that disease. This is one of the reasons why when we first, of course I was working in the laboratory when the AIDS epidemic hit. So one of the things we were seeing all these odd cancers and all these odd pneumonias that we had never seen before. The only time we had seen them was with individuals that were old, that were individuals that were living in squalor. So they were coming in contact with a lot of this stuff, and they were dying from these pneumocystis pneumonia, for example. Pneumocystis pneumonia, both of us are in contact with pneumocystis right now. But neither of us have pneumocystis pneumonia. Why? Because our immune system knocks it out. But these guys, all of a sudden, they were developing pneumocystis pneumonia. It was killing them. Pneumocystis pneumonia was killing them. And it's one of those diseases that your immune system always knocks out. No problem. And all of a sudden, these guys were dying from it. Another one is Kaposi's sarcoma. Sarcoma is a cancer. It's a cancerous growth. We only saw this in extremely immunocompromised individuals had Kaposi's sarcoma. And all of a sudden, all of these guys with AIDS are dying from Kaposi's sarcoma. Why? Because their immune system wasn't working anymore. They didn't have any T helper cells. So one of the things that we do if somebody is suffering from AIDS is we have to look at the number of T helper cells they have. Because if they have a T helper cell that has had its DNA replaced, then we won't pick it up. It doesn't come out as a T helper cell. It looks like something else. And of course, that's what we do. We count the T helper cells to find out how immunocompromised these individuals are, as strange as that is. Another type of T cell, the T of course stands for thymus.
Another type of T cell is a T killer cell. This is a cell, this guy attaches the interleukins and the lymphokines to it, and the T killer cell wanders off and it kills it detects the antibody, and it goes to that site and it kills the cell. It destroys the cell. The T suppressor cells suppress the humoral reactions. At the same time that we have our immune system that's working extremely well, we also have a possibility of it working too well. And if it does work too well, then we have a situation known as an autoimmune disease. Lots of autoimmune diseases out there. Arthritis. There are forms of arthritis that are autoimmune diseases. Lupus erythematosus is another type of autoimmune disease. If you know who Selena Gomez is, okay. Selena Gomez has lupus erythematosus, however you pronounce that word. The funny thing, so here we have this word, erythematosus. I can spell it for you. I can pronounce it for you 3 different ways, but there's a reason why it's pronounced three different ways. Lab techs pronounce it one way, doctors pronounce it another way, and nurses pronounce it another way. Isn't that bizarre? Usually it's the Brits and the Americans that are arguing about how to pronounce words. But no, we have doctors that study and the way they pronounce words is very similar to the way the French pronounce words. And the nurses pronounce words the way the English pronounce words. And lab techs pronounce words like Americans, okay? So we're Americans. And it really all depends, on who you're talking to as to how you pronounce these words. So erythematosus, erythematosus are just 2 different ways of pronouncing the same word. Besides B and T cells, of course, the B cells come from the long bones and the T cells come from the thymus. Major leukocyte in circulation is a cell that does not require an antigen to trigger the immune response. These are known as natural killer cells. So if I come in contact with the flu, probably natural killer cells are going to knock it out. If I come in contact with chicken pox, it's probably going to be a T cell will attach an antibody, and then a T killer cell will kill it. But these natural killer cells just wander through your circulatory system, finding strange diseases. They're floating around. They're granular lymphocytes. They recognize stressed or alien cells, and they destroy them with an antigen-antibody connection. This cell is produced besides the thymus or the long bones. It also comes out of your tonsils and your spleen. Do you have tonsils? Did you have your tonsils taken out? No? So you still have tonsils. Okay, so potentially that's where your natural killer cells are, in your tonsils. Or in your spleen. You still have a spleen. I don't have either a spleen or tonsils. I had my tonsils taken out when I was 20. I lost my spleen in 1985 when I was 38. Yeah, I was 38. When I was 38, I lost my spleen. So I don't have either of these guys. So where the hell are my NK cells? My natural killer cells. You've got 2 repositories for these things, your tonsils and in your spleen. Your spleen's right here. I know exactly where my spleen used to be. Because I've got a scar right there. Okay, so where are mine? Well, mine are circulating. Yours are sitting there waiting for something to happen, and mine are circulating through my system. And because of that, that may be one of the reasons why I never get sick. Because if I come in contact with the flu, or if I come in contact with anything, I've got natural killer cells that are already circulating, looking for something to kill. Thank goodness. I am not immunocompromised. I guess that's part of what I'm trying to say. While most leukocytes circulating in the body are granulocytes, various organs will act as staging areas or modification areas in case of a viral invasion. The spleen is the major staging and modification organ in the human body. This is one of the reasons why if you get sick, you're going to get sick, and then your spleen is going to kick in and destroy the bacteria. So, or the virus or whatever it is. So if you catch a cold, which is a viral infection, it's a rhinovirus. If you catch a cold, what will happen is you will be sick for just a number of hours, or maybe a day. You'll feel sick for a day, and then you'll have a runny nose. But you're not going to actually be sick anymore. The first day that you catch your cold, you're going to have the flu. You're going to have a fever. Your joints are going to ache. Your body's going to ache. But it's only going to last for a short period of time. It's only going to last for maybe 12 hours or maybe 24 hours. Even if you don't treat it, even if you don't do anything to it, you're still only going to have the fever for a short period of time, and you're going to be achy for a short period of time. However, let's say you've caught a cold. You're going to blow your nose for a week. Yes, you will. It doesn't happen to you. You've got a strong immune system. And that may be because you're outside all the time. And you're doing a lot of things outside. And because you're doing a lot of things outside, your immune system is attuned to reacting. And because of that, you don't get sick. You don't have to worry about
Or
that.
cold.
Yeah, you don't catch colds.
Or no, like actually get cold.
Oh, you actually get cold, yeah. So I told you guys that my normal temperature is in the 96 range. You know, you may be the same way. Since you're outside all the time, then your core body temperature is a little bit lower than everybody else's. Well, viruses are very fastidious. They need 98.6. They need 97, 98.6. So since you're outside all the time and your core body temperature is a little bit colder than everybody else's, you don't get sick. I mean, it's very logical. The Germans will tell you that the healthiest way to sleep is in a cold room.
Sleep in a cold room every day.
There you go. So that may be another reason, because your core body temperature is lower. When you go to sleep, when you first go to sleep, your body temperature is whatever it normally is. If you're at 98.6, it's at 98.6. But as your circulation will decrease as you are asleep, especially when you go through delta wave sleep, your core body temperature will actually go down. And because of that, if you're sleeping in a cold room, of course, then your core body temperature is going down lower. So whatever horrible monster bacteria and viruses are in your system, they can't survive in that environment. So they will die. And I know that sounds tragic, that all these viruses are dying. You're not getting sick. But let's take somebody else. Let's take an individual that lives in a hot house, in a house that's relatively warm. In the wintertime, of course, with the flu all wandering around, since they're in a hot environment for an extended length of time, of course, they're going to develop these problems. Now, since they have a repository for all these NK cells, they're going to have to get sick before the spleen will kick in. But once it kicks in, and that's one of the reasons why they will only be sick for 12 hours. They really will only be sick for 12 hours. But they will have a nasal reaction. The mucous membrane and the sinuses are really very delicate. So if you irritate your sinuses, they will try to protect themselves with masses of mucus. And so all it is a reaction to blowing your nose. And that's why a cold lasts for either a week or 7 days. Because most of it's just a reaction. You're not really sick anymore. You're just blowing your nose a lot. So you're not really sick. You're not contagious. You're only contagious for 12 hours. But your body has defeated the bacteria, or the virus in this case. Your spleen is kicked in. The NK cells have gone to the site. They've destroyed the virus. And now your mucous membranes are going to just react to it. That's just the way it works. Spleen is extremely important because it's a staging area for just about all of your white cells. And that's the reason it's there. If you have a spleen, I don't, but if you have a spleen, and you've ever had a disease like strep throat, or if you've had it over and over again. I had tonsillitis a lot when I was a kid. Because of that, my spleen was enlarged. Why was my spleen enlarged? Because I was sick so frequently that my spleen enlarged with trying to protect me. So one of the reasons I ruptured my spleen was because it was so large from all of those tonsillitis, from all those infections I had. So when I got hit in the chest, it burst, it exploded. So that's one of the reasons why I don't have a spleen. The spleen normally contains about 40% of your NK cells. It contains about 35% or 25% of the B cells and 10% of the C cells. And so you can see why it is so important to your immune system. Are you asking a question?
Yeah. So like when someone's sick around me, you know, my body attracts it. Even if it's like 12 hours, like before that, like example, last year my sister got the flu, and she was sick for like one day. But during that day, I was around her, and I guess my body attracted the sickness.
Sure.
And so within hours, she was over her flu, and she was okay.
Right.
Then I got the flu, and I got over it quite quickly.
Sure.
Does that mean like my
It means your immune system's working.
I mean, like, did my body subtract the flu?
No, it's, I'm probably attracting the flu right now, just touching these tables with my hands.
Oh, my sister, she doesn't really have that strong immune system as like
Right.
me.
Right. You didn't really attract it, you just came in contact with it. And, you know, of course you're going to get sick because you haven't come in contact with the flu since last year during the flu season. So sure, you come in contact with it. Your immunity is not against this flu, it's against last year's flu. So you can't fight it off. Your body doesn't really recognize it. It's one of the reasons why it's so hard to fight off the flu, or to develop a vaccine against the flu, because we don't know what it's going to look like this year. We don't know the configuration. It mutates every year because the Asians live with their pigs, okay, or they feed their pigs their own human waste. Really strange situation. So when you came in contact with it, your body didn't recognize it. Since your immune system's so strong, you fought it off really fast. Your sister, her immune system's not as strong. It took her longer to fight it off. But you became sick, but only for a very short period of time.
Oh, well, she did too, like only for a little bit of time, then she came in contact with me and she got over it.
No, it's not like a magnet where all of a sudden you pulled the flu out of her.
I don't know, it was weird though. Like, I was like,
She's got evidently she's got a strong immune system as well, and she just fought it off. Uh-oh, it's time to stop, I'm sorry. So we'll pick this up next time. Like I said, this is one of my favorite chapters, mainly because I worked with this stuff for 30 years.